Use a text that I used in class recently. You can see I already started doing this, and then I realized it was not under my doc so we're going to start over. All right, so 2.1, it's from chapter 2, force the push or pull. Went over that in class. Okay, so now let's look at this diagram. So applied, it sounds like applied for a job, but I don't think that's what that means. So I'm going to ignore that word for a moment. Net means total. So the total force and the applied force. Okay, well, so here we go. So what's happening? 5 and 10 and 15. All right, so am I adding? All right, looks like I'm adding these up. So 5, 10, 15. Nope. Okay, so I'm not still adding. So 10 and 5, 5 and 10, what's different? All right, these two are in the same direction, but these two are in opposite directions. Okay, so add if forces are the same direction, but subtract if they are opposite directions. Okay, so what's this going on then? Is that true? So 5 newtons is right, 5 newtons left, 0. Yeah, okay, so that's right. All right, so the net force depends on the magnitude, I don't know what that means, and directions of the applied forces. Okay, so yeah, it depends on the numbers. Maybe this means amounts. And directions of the applied forces. All right. So this video is not a bazillion years long. I'm gonna just only annotate above this and think aloud for above this. All right. So going back now to the text, now that I've looked at my diagrams, because that's what a master science reader does, is look at the diagrams first. Okay, force of pull. Force of some kind is always required to change the state of motion of an object. What does state of motion mean? All right, I'm going to ignore that for right now and come back. The state of motion, oh, here it is again, may be one of rest. Okay, that means stop. Or of moving uniformly along a straight line path. Okay, uniformly, I'm not sure what that means. I'm going to ignore that. All right, so a state of motion may be one of being stopped or of moving along a straight line path. Okay, so it means moving along a straight line path. All right, so I'm going to ignore this. So state of motion is either stopped or moving. So I'm going to read this sentence again. A force of some kind is always required to change whether or not the thing is moving of an object. Okay, so that makes sense. A force is needed to move it or stop it. For example, a hockey puck at rest or stopped on ice remains at rest until a force is exerted. That means like put on it. Once moving, a hockey puck sliding along the ice will continue sliding until a force slows it down. So again, a force needs to start it moving or stop it moving. A force is needed to change the object's state of motion. All right, this is in bold, so that's obviously super important. All right, net force. Most often, more than one force acts on an object. The combination of all forces acting on an object is called the net force. So this is what I saw over here. That's the total. The net force on an object changes its motion. For example, suppose you pull horizontally on an object with a force of 10 pounds. Okay, so horizontally means like this way. If a friend assists you and also pulls in the same direction with a force of 5 pounds, the same direction, the net force is the sum of these forces, or 15 pounds. Okay, wait, this is talking about this diagram. So 5, that's my friend, 10 is me, 15 is the total. Is this N? Is that a symbol for pounds? Okay, so I'm not sure about that. We'll come back. All right. The object moves as if it were pulled with a single 15-pound force, right? However, if your friend pulls with a force of 5 pounds in the opposite direction, oh yeah, so this guy, the net force is the difference of these forces are 5 pounds towards you. Difference, I know my math teacher told me, means subtract. So yeah, so that supports that. Okay, the resulting motion of the object is the same as if it were pulled with a single 5-pound force. This is shown in figure 2.1. Yeah, I already saw that. Where instead of pounds, the scientific unit of force is used, the Newton. Oh, okay, so newtons and that's the Newton does not equal, all right, does that, and that's abbreviated N. Okay. And the other thing I would look at is the superscript 2.11 refers to a note in the text, so that's not particularly important. I might cross that out. All right, that's my think aloud.